Hey, today we are going to work on some modeling problems, which is just doing a few word problems. And we're not going to use an IMB, we're just going to work on a little bit of a worksheet. And it's going to be our section is 5.5 in the book. And we're going to start off with something we've already done, which is compound interest and continuously compounded interest. But this time we should be able to solve for the E algebraically. And I know there was a couple students that kind of felt like they still weren't clear on that. So I'm going to go over some of those problems. So the A in the compound interest is your final amount, and your P is your principal or your starting amount, and it's not a principal like principal, starting amount. Your N is the number times compounded in a year. Okay, and T is time, that's in years, and R is your rate, which is going to go like, so if you had like 6.2%, that would be 0.062. Okay, and that takes care of all of those for both of the continuous and the compounded. So let's do a couple of these and we'll show how to work these. Let me just get my calculator going real quick. And so it says, suppose on each day you were born, your grandmother, so we're going to kind of go over this one real quick. And $10,000 at 8%, how long would they count to reach the 50,000? So yearly would be 1, quarterly would be 4, monthly would be 12, daily would be 365, continuous is per. A is equal to E to R. Okay, and good thing they didn't have, oh, monthly. Good thing they didn't have weekly. It's a little off last time. Okay, so you're just going to work this out. You're going to write out the equation of the compounded interest, and you're going to say A is equal to, we'll just fill it in. How much is it going to take? How long is it going to take to get 50,000? I initially put in 10,000, and I have 1 plus my rate, which is 0.08. And I'm going to divide that one by 1. So I'm not going to even worry about that. That just comes out to 0.08. And I want to know my T. So I'm going to divide my 10,000 and my 50,000. So I get 5. Remember, we talked about it's just asking, when is this going to be 5 times the amount? And now I'm going to do my log. So I'm going to do a log base of 1.08. The input of this log is the output of the exponential, and it's output in 5, which is equal to the input of the exponential, which is the output of the log. That's the definition of an inverse. I'm just going to go to my calculator. I'm going to hit second, or not second. I'm just going to hit math, hit the up arrow, get you there a little bit quicker. And I'm going to put in log of 0.108 and 5, and I get 20.9. Remember, you could also use, like, say you don't have this updated version of a calculator, maybe you're on a TI-83. I can also use these log or natural log buttons, and I can say log, and I can put in the input amount, 5, and divide it by the same log, so another log base 10, and then put in the base as the input, okay? And then that will get you the same amount. I could use natural log, 5, and then divide it by the natural log of 1.08, and that will get you. So that's a workaround if your calculator doesn't have this upgraded software where you can put in the log of 0.08. You can just change the base. Wanted us to be aware of that. Okay. So the next problem is quarterly. So instead of each time like dividing by 10, I'll set it up. But soon we're gonna realize that every single time I do this, I'm gonna first divide by 10,000. So it's just gonna be equal to 5 every time. And I'm gonna do 1 plus 0.08 divided by 4. That's our quarterly compound. So I'm just using this equation where my n is up here. And then I'm going to put n and t. So now I have a 4 up there. So I have 5 is equal to, and now I have 1 plus 0.084 raised to the 4t. Okay, so I might want to get that base right here simplified down to a fraction, to a decimal. And you kind of want to take these out quite a bit for it to be really useful. So I'm going to split screen my calculator. Oh, if it'll cooperate. Okay, and so I'm going to put in here 1 plus, I'm use parentheses around my fraction, divided by 4, and hit enter. And well, that one ended up being a pretty okay number. So I have 1.02 raised to the 4t. So this time I'm going to take log 1.02, input 5, output. This time there's a 4 there. So I'm going to divide. I'm not going to divide the 5. I'm just going to plug in, go to my math up here, go to my log base, and I'm going to plug it in. I'm going to say 1.02, and I'm going to plug in 5, hit enter, divide by 4, hit enter, and the t should be all relatively pretty close. Okay. Conversely, I could have done, if I didn't have the updated software, I could have used natural log. That's a common one used. And I could say the natural log of 5 divided by the natural log, whatever the base of the other log that I want to get out of that base, because I don't have that in my calculator. Plug that in, hit enter, and then divide it by 4, and you'll see I get the same exact thing. Okay. And I'm going to assume that you can do monthly by just substituting 12 in for here and doing daily by substituting in 365 for where my 4s are. Okay, and then I'll just look at PERT real quick, and I'll say I want an output of 50,000, an input of 10,000, E, and my rate is 0.0 raised to the T. Again, I'm going to get 5. This one's a little bit different because I have a base E, so I'm going to use natural log 5 output 0.08t divide, boom, boom. And this one, there's really no workaround because it's already in your calculator. So I have log of 5 divided by 0.08, hit enter, and I get 20.11 years. Okay. The next one is exponential growth and decay. So let's define each one of those. Y is equal to your final amount. A is your starting amount. And some other variables that can be used for this is n naught. Like sometimes they use A, sometimes they use n naught, meaning initial, and sometimes they still use P. Okay, all meaning the same amount, starting amount. Okay, so, or you can do, I think there's one that's M naught. We'll talk about all of those, but these all mean the same thing, starting amount, and they're in the same position of the equation. K is your growth rate, which is positive, or decay rate, So it'd be negative. T is time, and that's going to match the rate units. So it can vary, and E is approximately 2.718, right? Dot, dot, dot. Okay, so exponential growth, you can see it as y is equal to a e to the kt. Remember where these are all where k is greater than 0. You can also see it if a lot of times in populations, they'll write it like this, where n naughts for the starting population. Notice really not any difference there. Very similar to the PERT that we just did, where rate would be your constant or growth rate. And we also had the one where it's like 1 plus the rate to the t. Okay, exponential decay, you can have y is equal to a e to the negative kt. You can have half-life. Remember, if you're half of the initial, your ratio, like the one above was 5 times the amount, then it's always going to be a half equals e to the negative kt. And we'll go over that one. Okay. So usually these are a two-step process. Usually you're always going to first find k. And 2 is use k to answer question. Usually you're always going to have to sidestep and go, I can't answer the question yet because I have 2 variables. So I'm going to have to first solve for my k. And now once I have k, I can go back and answer the question with k plugged in. And we'll look at an example right here. You can see part 1 and you can see part 2 there for us. Okay, so this says half-life of carbon-14 is this many years. Okay, so we don't know our constant. We know our constant or our rate is negative. How long will it take a sample to be 5% of its original amount? So this part right here is part of the equation. This gets me k. Now, this part of the equation is part 2. Once I know my k, I can answer the question that I'm after, okay? But I can't answer how long it'll take for 5% of its original amount if I don't know k, because then I would have k in the equation as an unknown, and I'll also have t, which I'm trying to find out. So I've got to find one of those. So part 1, find k. Now, remember, we're just going to use our decay. And you can use the half-life equation, but I'm going to just show you that these all are the same equation. So y is equal to a to the e to the negative at. Now remember, it didn't tell me how much of a substance I have, but you could say, hey, initially I have 10, and so I'm going to end at 5. And guess what? The first thing that you're always going to do on this is divide by 10. And boom, you're always going to get that ratio of 1/2, right? So when you're talking about half or double or 5 times, they're giving you the output is gonna be 1/2. Or if I wanted to know how long it'd take to double, if it was a growth, I would just, it's telling you the outputs too. Okay, and I don't need to worry about the input or the original amount, and the final amount. Those are taken care of by the half. Now, what I want to do is I want to find k. I know it's negative, and I know the time it takes to go through a half-life is 5,730 years. So that's what enables me to find my k. Okay, so now I'm ready to just go ahead and convert this into a log. Natural log of 1/2 is equal to negative k times 5,730. I'm going to take that and divide it. I'll take the negative with it. And I'm going to have to put that in my calculator. So I'm going to go natural log. I'll be lazy and just put in 0.5. Hit enter and then divide it by negative 5,730. It's going to be a really big, oops. It says syntax error, always go to, and it should tell you I didn't do the little negative. And I'm going to hit enter. Now this 1.209, notice it says e to the negative 4. So k is equal to 1.210 times 10 to the negative 4. That is your calculator giving it to you in scientific notation. That e to the negative 4 at the end means it just didn't have enough decimal places to put it as 0.000. It's going to write a small number. So we know it equals 0.0012. Let me see, did I have enough? Nope, I missed a 0. 3 zeros, right? So I move it right 4, 1, 2, 3, 4. I get back my answer. Okay, so that's what my K is, and it's negative. And usually the rate's very small. If you think about it, for this carbon to become half of the mass it originally was, it took 5,730 years. That would be a very, very, very small rate of decrease. So that makes sense. Part 2. Now I'm ready to answer my question. I want to know how long it takes for 5% or 0.05 of my original amount. So this is kind of saying half. Remember, half is just a percent, 50%. So I could have said, I want to know the 50% rate or the half rate. So same thing. I don't have to worry about an initial amount. And I'm going to put this time negative 0.000121 t. Now I'm ready to natural log 0.05. And then I'm going to get raised to the equals negative 0.001210 t. And I'm going to divide to get my t by itself. Okay. And this is how long it will take. And you can plug it in, but I already have the answer written down. I'm not going to go to my calculator because this is already taking a little while. So it's 24,764 and 648 years. I might say, wow, that's a long time. But remember, it took 5,730 years to be half of what it initially was. Now I'm asking when it's only 5% of its original amount. So it's going to have to be quite a bit longer than a half-life. Okay, so we're going to stop there today, and I'm going to assign you some book problems, and then tomorrow I'll finish this up on a video, and there's one left on another culture modeled by a growth, and then we'll look at one logarithmic scale, and then we'll be done modeling, and we'll start to practice for another quiz and our final test. See you tomorrow.